Okay, should be live. Uh, yeah. So I was just setting up a new server that is actually going to be my first Apple Silicon server, and like home server. And I was just reminded after I got the thing installed by Jen now that U-boot USB support is broken with certain disk enclosures, like the one I was planning on using. So it all goes completely wrong and just breaks and faults and reboots it, and basically explodes into bits and pieces. And yeah, so I guess I get to fix that now. So let's just as a bit of background first. I have a history with USB. I think I was 12 or something when I was making a thing with a PIC microcontroller, and I needed a USB device stack, and the official one was written in C, and the official C compiler was absolutely horrible, and I didn't want to use it. It wasn't even free. And so I rewrote that device stack in PIC assembly language, which, if anyone is familiar with that, is not the nicest architecture. And ended up debugging it on paper because it wasn't working, and I had to go over it with a highlighter pen to make sure that it all made sense. It's like I printed it out. And yeah, I think USB has been haunting me since then. I was involved in the development of a USB analyzer called the OpenVisla. And I wrote the QEMU XHCI virtual device. It was actually a code dump because I was working for a company that wanted that back then. It was a short thing I did, like my second job or something. So I wrote it for them, and we were going to upstream it, but it was like a code dump thing, and someone else took it and ran with it. And I've looked into bugs in the Linux XHCI code, into weird vendor-specific firmware nonsense. There's a lot, and then USB PD stuff with the Macs, and it just never seems to stop. USB seems to just want to haunt me forever. So let's see what on earth is wrong with this U-boot stuff. So let me switch to the screen and show you what actually happens. Actually, let me close a bunch of stuff first. Okay. And let me get some drinks because I'll be thirsty otherwise. So this is the explosion. Something goes wrong. And there's multiple layers of fail here, because the first layer of fail is what causes the thing to start breaking. And then it tries to queue a URB on a halted endpoint, which is wrong. And then it gets a TRB and it skips it, and then it null pointer dereferences. So there's probably at least 3 fails here. So we're going to go backwards, and we're going to fix the fails, in reverse stack order, so that at least, then if other things break in the future, it doesn't just crash. So the actual failure is there, and I think Jan mentioned this. Where was this actually? Was in lore. That. Yeah, so the first problem is there's an XHCI wait for event that is returning null. Is that drivers USB host? That's an XHCI ring event. That's in ring. Yeah, so that, where was that? Wait, XHCI, wait for event control transfer event. Hold on. Oh, they're kind of confused what's going on there. XHCI, it's in 546. Oh, here. Okay, so yeah, so those are every place we have that, we have to just return null there. So some of those are already guarded, but not all of them. Like that one. So then what, we had those in more than one file though. We want that in xhti.c. Let's check that. Yeah, so there's more than one. And he timed out. Timed out, or something like that. I need also one here. Okay, so that should at least make it not blow up, which is a pretty good start. So let's see if that fixed the explosion. Wait, what? Oh, God, why does it do that? It's like now it thinks this is the kernel and it's trying to... there's a weird thing with the... Like, I don't know why the like Clang LSP thing here is adding includes. How do I get it to not do that? Include declaration? No. I don't know how to turn that off. Anyway. Yeah, okay, so now it's stuck there. And it's probably just going to be very stuck for a while. I hope it recovers at least. Let's see what happens. So if it's an infinite loop, that's not good. But I'm hoping it's going to just give up. We're going to leave it running that, and I'm going to do a git commit since might as well. Okay, that doesn't seem to be going very well. I wonder what it's doing. Unfortunately, the backtrace isn't very smart right now. It'd be nice if I could load the symbols for this and get it to work, but... Do we have a symbol file I can use for this? Just a map, yeah. U-boot. Doesn't help. Because it's relocated, and it would be nice to have... Do I have a thing for the offset in the hypervisor? I think I have an offset. So yeah, sim offset. How do I set that? Yeah, that's only set for X and U, but I need to set it for something. I think it's VD410. Oops. Why did that explode? That's not nice. I'm not sure what that was about. Hey, Colin. So yeah, I'm trying. I installed Fedora, and I'm fixing bugs in U-boot because U-boot USB support is kind of broken. Oh, I can answer here. What did it try to like deref a thing and somehow derefed it with the offset? I feel like this, and I'm recursing bugs. Where do we use sim offset? We use that to get unslate address. Oh, I should have used negative for that. Okay, let me try again and just see what it's doing and see if I can at least make the hypervisor work. Okay, so it's only already get stuck there. So I think I need that. Yes, but no. But I probably have the wrong offset. Oh, no, because I didn't load it. Aha, yes. ext4fs. No, okay, I think I have the wrong offset, but at least it's vaguely looking. Ooh, as media. Yeah, I don't think that's right, but close. Where is the offset? Where do I get that? Surely something tells me that somewhere. Is that in the maybe it's BD4? No. I had a print before that actually told me that. It is BD4 1. Oh, no, 0, 4. Okay. Ooh, and it failed. Oh, wait, isn't that that's the watchdog, isn't it? How do I turn that off? I guess turn off yeah, of course it's the watchdog. Was watchdog auto start? No. Yeah, okay, that explains why that breaks. Actually, let me just make this work with U-boot instead of having to use the kernel. So, actually, no. It'd be nice to have another system map thing. Maybe I can do that. Actually, let's just add a U-boot option. And then I need the device trees. I don't want to get those from the kernel, though. Nah, okay, whatever. I'll just do it manually. But I'll just add a system map option. Okay, so yeah, I had some messing around getting the kernels built and also learning about like SE Linux and stuff. It was kind of interesting. Okay, so -k-n system map, and then I need the I think -c works. So I can just set I think we have more than one -c. Let me just check that. Proxy client tools, run guest. Yeah, append, okay, yeah. So in theory, I can say hp dot what I did there. Same offset equals that. I think the -- works. Yeah. Oh, there's a tab. Yeah, I think that should do what I want, mostly. So, oh, and wait, that was a 4 there? Wait, no. Oh, yeah, because it already crashed. I think it was 4 like that. We'll see. Let's try that. Oh, I typed it. Okay. Aha, yes. That is what I want. So it's doing a partition in it, trying to do block reads, USB store read, and it's failing on USB store bulk transport. So it's failing on a bulk message. How are we ending up with resetting EP0? That's already weird. Then the other thing is, what is the actual unexpected HCI event TRB? What is that? So now we look at the USB spec, because of course. I think I have XHCI somewhere here. No. Oh, it is there. It was just the long name. Yep, USB 500 pages is the XHDI spec, which isn't that bad as far as the USB specs go, but yeah. Okay, so where's the TRBs? Event TRBs. Where's the actual spec? Event TRBs. So the TRB we got starts with a D. We care about the last bits. TRB type. Where's the type IDs? Table 139. Table of tables, I guess, of course. Okay. So the bits I need are 10 to 15 on the last one here. So the type is hex 21. Is that the right? Yeah, 15. It should be 6 bits. So that is correct. 21 PRB types, which is 33. Command complete. It's a command completion event. Okay, why does it say that's unexpected? Because it's expecting something else. So something is definitely desyncing here. Okay, so the first thing I'm going to do is just put a while one here, because by the time we get there, we know it's very broken. And so then I can backtrace it in the hypervisor. Yeah. Forgot to fix that. Here's where we are right now before it starts failing. It's in wait for event again. So it gets stuck in wait for event. So it looks like it just, first of all, it's just timing out on some event. And that's really stuck. Oh, wait, is the print not flushed or something? I think we just got stuck there already. How do I make it flush the console, though? Maybe I can just bug. Hey. Is there a thing for console flushing? Console flush support. Oh, yeah, I need to fix that. Wait, flush to imprint? What do you mean imprint? No, this is C. I mean the U-bit stuff. Okay, that just rebooted. Bug. Yeah. Wait, but why didn't it print? What? Why didn't it print that? Oh, no, because C. Because C. Do you use VPN? You don't like WireGuard. I'm actually going to be switching to WireGuard as part of. Why do I keep forgetting to do that? As part of this big change to the server stuff. I have like an IPsec thing locally, and I have an OpenVPN thing remotely, and it's like ancient. And I've been meaning to switch to WireGuard, and I've been putting it off. Okay, so now it's doing what I want. Okay, now we're stuck there. So it's in abort TD. So it was expecting what? It was expecting 32. It was expecting a transfer event. It got a command completion event. Command completion is used for the command ring. So let's see what command completed. Doesn't really tell you though. So the completion code is 3124 on the second word. So in this case, the completion code is 13, which is 16, 19. Context state error. Okay. That's pretty bad. Okay, so this might be a configure endpoint return. I should just start printing out all commands. I think I'm gonna have to add more debug first. So let's go into debug mode. So reset EP, resetting EP, yeah, Q command. So XHCI Q command. Yeah, I mean reset EP is a Q command, is a command, so that might be the issue. It's not really mentioned though. Okay, so let's go to Q command. And that is here. Control DMA address. Okay. And the completions give you the address of the command TRB. So you want to print that. How do we print that? QTRB. Vert to DMA. Oh, it just returns it. Okay, yeah. I think that's fine. Actually, just add a print here. And it's returning the in-queue segment and the TR. I'm already wondering if there's a bug here. What if it goes into the next... Hold on. It's incrementing in queue. If last TRB... Ring and queue... Yeah, that's already a bug, isn't it? Pretty sure that's a bug. Because we are looking at the wrong... I think it does before increasing the in-queue. So that's one bug, though. I don't think it's our bug, but it's a bug. Okay. And then we can actually do the print here, and that's going to be correct. Address. One, two, three. How about those containers work on Asahi? Yeah, they should work as normal. I mean, as long as it's running ARM64 stuff. Okay. Did I lose something there? No. Also, hold on. Keep forgetting to fix that. Let's do that now. Oh. Oh. Okay, so we get some commands. Why did the enqueue stuff not work? Oh, no, it's not. Where did I get fprintf from? And why did that not fail to compile? Hold on, what? Is fprintf a thing? I guess. Okay. Okay, there we go. Now we had a lot of TRBs. And we can see the last one here gets stuck. Okay, so now we know the one that failed. So the one where it got stuck was D0129EB0BD. Hey, so it is the previous TRB. It's literally what it just queued. Why is it waiting for an event that it just queued? Okay, so what did it queue? As I said, we definitely have recursive fail here. Okay, so command TRB is 2215. Is that right? I think it's right. Type 15, yes. What is command 15? Stop endpoint command. Sounds legit. Okay. It does a stop ring. Why are you waiting for a TRB transfer? This should be a completion. That's a bug. Or is it waiting for like another TRB to come in that is... Okay, hold on. Let's see what that's supposed to do. So stop, endpoint command. Okay, so it's waiting to get something related to the transfer, but that's not guaranteed because in this case the completion is failing. So the problem is this is getting called without a transfer ongoing, but also this is dumb because it should be expecting possibly both event types, and now it's just throwing it away, which is making everything worse. So let's fix that first. Make it at least more robust. So we have the wait for event expected. Okay, let's look at the TRB type enum. Where is that? We need something. Actually, it's a that returns the whole TRB. But I probably just want a special value for that. Just say like any. TRB type. Just TRB type. Is 0 used, or can we just say reserved? Yeah. Let's just say TRB none. Let's format it like that. So then wait for event, where we do the abort TD, we can say TRB none. And then we can check the event type, which is like that. So then we do that. Transfer. Type. Okay, so we print that, and then we go on to this part. Okay, so then we can say so we're going to put a bug on there to make sure we always get the completion there. And we can try that. And again, we're like recursively fixing stupid stuff right now. So the other problem is that, actually, let's do a print here. Storage type is not none. What? Is it just DRB type? Yeah. Also, DMA address long. Okay, yeah. Okay, now what? Now we have a bug on abort TD. So let's not turn that into a bug. This shouldn't happen in practice for current users and it's too complicated to fix right now. Yeah, really. Too complicated to fix right now. Okay, so what we did was a stop on commands 0 to 215. That's... Is that right? slot. So we have slot 2, endpoint 2. Is that right? I think that's never started. I think it's trying to stop an endpoint that was never... Hmm? Okay, so who is calling abort TD for starters? Okay, let's do another add here. Without the print. Okay, so that's that, that's that. Then let's do that, not those. Okay, so that's... Oh, I think I forgot something there. No, that's fine. Okay, so that's there. I mean, as usual, I am listening to Spotify here, but I don't stream that because that would get me in trouble. So anyway, I think this is the same error we had before. Was it 10? No, wait. Uh, it is 10. Hold on. CF, so 15. So now it's a different error. Ring overrun? No. Wait, am I thinking this wrong? No, that's the sent TRB, not the returned one. I need to print the events. So we get 2 events, actually. We do get one for the 91st. So now we are getting a transfer event first. And then we're getting, so that's what? 10 E0. Okay, so that's a 32. Event lost? No. What? Am I getting that right? Hold on. No, I think it's the wrong. Oh, it is 10. And then an 84? No, wait, hold on. TRB types. Sorry, no, okay, it's a transfer event. Yeah, so we get a transfer event, and then we get a combined completion event. And the transfer event, I'm confused. Completion code we got for that was 2. No, 1A. Just 26. 26 is stopped. Yes, that makes sense. So that's actually working as intended. And then the other one got a 2, a 1, which is success. Okay, so why is it bugging? This is a bunch of prints. Oh, wait, I forgot to, no, okay, I forgot, the type, I forgot to get the type again there. Okay, that's my bug. Okay, so we got one timeout and one abort, and that one did what we want. So the general abort path is fine. And then okay, so resetting endpoint 0 doesn't make any sense. I think something is messed up there. Because we are halting endpoint 2, and then we're resetting endpoint 0. That doesn't make any sense. I think that's fucked up. Actually, does that even... Uh... Okay, let's turn on debug for that. I assume you just do that. Is that even right? Do you reset endpoint 0? Because I thought stalls on endpoint 0 are special. Yeah, I don't think you do that. That's a normal condition, I'm pretty sure. For endpoint 0, which is special. Ooh, okay, let's have debug now. No, yeah, this is USB 2. There's no USB 3 support here. Okay. So that's fine. And then we have that halted endpoint queuing URB thing, which is obviously broken anyway. So then we have a timed out bulk transfer. I'm going to add a debug there, so we can at least print when that happens. Okay. Yeah, so AP0 stalled, that doesn't mean anything. And then we are halted endpoint. Okay, so we are, I'm pretty sure in this control request type, value index, what is that? 20 request 255, that doesn't look right. I don't think that's right. USB device framework, device requests, request type, reserved device to host no. No, that's fucked up. I'm telling you, there are like recursive layers of fail here. Okay, let's see who was calling that. Okay, so we got that. Let's start backtrace. Submit control message. Storage BBB reset. Okay. Oh, wait, no, the request is FFFF. The, what's the type? Maybe that is right. Maybe. But now I need the, that means now I need the USB storage spec. See what the hell is going on with that. Do I have that? I think I do. Maybe. Maybe not. Do I have storage? Maybe not. Okay, let me download that. Yeah, bulk only. That's what I want. Not over. This is going to be the bulk only one. Okay. Reset recovery. Bulk only mass storage reset. Okay, what is that? The 13 cases? What? Okay, I think I need the main spec for that. Request codes. Okay, that is correctly the reset, sorry. So that's not wrong. But before I added that code, it says endpoint 0 stalled, and then it says halted endpoint queuing URB anyway. That's not right. pretty sure endpoint 0 is not supposed to be halted. Yep, it's a SCSI. Control endpoints. Error, stall error. Okay. Okay, no, so it does. Okay, so it does need the reset for endpoint 0. So we do need that. Okay, let's see if that's correct then. So I need to undo that. Let's not do that. So I'll just make that into just a log. I'll just append stuff to that commit later when I, actually, let's just add a bunch of the other stuff too. Wait, what am I doing? Yes, yes. Split, yes. Yes. Not that one, but yes, the... Leave that. And just add the expected. And don't add those. Oh, and there's a weird... Yeah, thankfully I'm going to have to deal with ISO here, but... I don't think Ubuntu's ever going to touch an ISO device. Hopefully. Okay. So there's that. Okay, so it says halted endpoint queuing URB. Anyway, that doesn't sound right. Also, that's missing a break there. Let's put that in there and see what it's trying to do. Prepare ring. Okay, so where are we? In bulk TX, we're trying to transmit on a stopped endpoint. So here we stopped endpoint 2. What's the pipe thing? So endpoint is that, down 15, and then... yeah, okay, I see what it's doing. So that's the actual endpoint number. The other thing is the index. So we got pipe. Yeah, so it's 1 times 2, and then pipe in or something. Yeah, so it's 2. So it's trying to send a message on endpoint 2, even though it is halted. That's not good. So, okay. Oh, no, it's also enable debug here. The direction is bit 7. Pipe in if 1. So that's a pipe in, and then the one we are failing on is still pipe in. 83, 83. You have the same thing there. So it worked there. How did we go from running to halted endpoint? That's not right. So we're looking for EP state, bulk TX, EP info. EP context is the I think that's a thing from the spec. Endpoint context state. No, something's not right. Yeah, so this basically the problem is that this is already halted. And we are it's already halted and we're trying to halt it again. That doesn't work. And the question is, why is it already halted? And there is some underlying fail here because okay, let's look at that EP info. Info 2. Let's look at all that. DQ TX info. Yeah, clearly we have a problem. Because we have an endpoint that is getting halted without us knowing why. TRBDQ pointer. Do the low bits here mean something? Yeah, the Q cycle state, and that's supposed to be the low 4 bits. Yeah, that's right. So B0 is the pointer. 3440B0. Okay, so that's the TRB that happened. Stall. Okay. Yeah. Hold on. Is this in the mass storage code? Who prints that? Okay, it's in USB storage. It says we need to clear it. But it's not printing the clearing endpoint pipe thing. Wait, no, that's not the same status thing. Hold on, where are we? Okay, there. That's not working, though. No, but... Special for BBB... What? No. But now, then the USB core code is going to be very... No. What? No. Attempt to read CSW. Yeah, so it's supposed to do it again after the... Yeah, so the problem is that if you don't actually clear it on the at the USB layer, that's not going to go well. USB clear hold, we need that. Okay, so that's another bug. That does the control message. Point running. Just mention the toggles. That only talks about the mouse reset. Okay, so it's just USB clear hold. I don't know who invented that. No, delete that. And the pipe is pipe. Pipe in. Okay, let's just add that. Actually, you know what? Git stash, and who do we blame for that thing that doesn't make any sense? Yeah. Okay, it's from 2003. Lovely. So this has been broken since forever. Since the very beginning. Yeah, no. This has been broken since forever. Well, this is U-boot, not Linux, but yes. Wait, Linux had USB before 2003. I'm sorry. Linux had USB before that. I think you mean U-boot. Well, yeah, I mean, I'm pretty sure I had USB when I was like 12, which was 2002. Okay, now what? Still halting. Why? Oh, did I forget to... Wait. Okay, let's add more debug here. Some devices are reported to lock up upon this check. Why is everything in USB and U-boot so broken? I'm 32. Uh... Okay, we do call USB clear halt. And that looks like an in1 endpoint, which is what we want. So why is the halt not getting cleared at the USB controller? Oh, it just... Wait, what? Is this not even hooked up? Yeah, so who calls reset EP? Control transfer. Is this just missing entirely? My God, seriously? Uh... Where are we? Drivers USB host. How do other drivers do it? What about EHCI? Okay. Stalled. Okay, so we also need to handle the context state error case because that's actually a normal race condition. So let's do that first before I forget. Where is that? Abort, or what was it called? Abort TD. Yeah, so we need that does not equal or. We have comp. Yeah. Okay, so we're gonna add a different thing there. Okay. Okay, that's another bug. Actually, I'll do an. Okay, so next, the reset thing. I think I'm just going to do it here in the bulk TX code. That's a control transfer, so those should always be cleared, but the bulk transfer here. Okay. That did not work. Okay. Let me also add that. I think we might have fixed the immediate problems. It's doing a lot of stuff, but I do have a bunch of USB devices plugged in, so that's not entirely unusual. So I probably want to unplug a bunch of them before... Yeah, okay, I think I fixed the immediate... Oh, look, it even picked up the hard drive. Capacity not available doesn't sound right, though. But it picked something up. Okay, so I think... yeah, it's logging a lot. I should unplug the keyboard and stuff, because that's not helping. I have a bunch of stuff plugged in. Let's get rid of that. And like a hub and everything. And... Okay. So now let's see how much spam it spams. I'm pretty sure there's still going to be... I mean, there's still bugs here, obviously, because I don't think it's getting the size, and clearly means something is broken with this controller, but at least it's not exploding. There is a timeout somewhere, though. Yeah, there. Okay. One storage device is found, yes, but not quite. Read error, command fail. Yeah, okay. A lot of things aren't working. Error status 2. So we fail on the second. We stall again. Is that inval or what is this? Error no. Enoent? No. Okay, that's the error status. Where's that USB stalled? USB defs. Yeah, that's stalled. Yep, so we are queuing a TRB, and then immediately we're getting a stalled event. On 2. I think that's a stalled. Let me double check that. It should be a transfer event. Completion code to data buffer error. Wait. Is that right? Hold on, this is TRB type. Wait, what did we just get there? That's E0. So that's 32. TRB types. Yep, transfer event TRB. Completion code. Data buffer error. Okay. That's a different problem. Then how is that getting translated into a stall, though? How? Actually, let's print all that. So let's not print the success case because that's boring. Short TX, I think. Yeah, that's fine, I think. Where is that? The completion code. I'll call XHCI com code. Okay. That's going to go in the more debug commit. And let's remove some of the other debugs because it's a bit too much. And this one is just a bug fix. It doesn't work. Okay. And honestly, that probably should be kind of a bug, but shouldn't even be a warning. Yeah, it could be related to the transfer size. So let's see what more carefully what the problems are now. There's our timeout. But after that, we get more stuff. So recapacity doesn't look right. But also, all these events, I think I got the event, I was reading the completion code wrong. Yeah, it's slot ID, and then the completion code is the previous one. Okay. which is a 1, and completion code 1 is success, so that's fine. And then it times out on this one. Gets a 1A. 26. Stopped, yes. So that is legitimately timing out. And then after that, it does a reset. So we're getting a 6 now, and I think that's a yeah, stall error. Okay, so it is a stall error. Oh, is this one of those things where the capacity is too large? Yeah, I think so. Because this is a like 8 terabyte hard drive, so that's a different problem. So we probably also want to fix that. And that's just the SCSI thing, isn't it? Yeah, FFFS max. Yeah, okay, so there's just a better thing. Read capacity. I'm guessing U-boot doesn't like. Let me check with the LB, I think, because U-boot might just not support that at all. Oh, there's an LBANT, okay. Yeah, I think we just need to add LBA48 support. Yeah, the IDE driver supports that. What depends on that? Is that just in block? Oh, but you need config this 64-bit LBA. That's what we need. Yeah, that's the one we actually want. So Let's implement that, because that's easy enough. Well, all right, yeah, never mind. And I want, it's a 16. Parameter data. Yes, it's 32 bytes, so right, so the command is 10 bytes and the return is 8 bytes. So that's right. And then in this one, it's 32 bytes. So we need 8. What sense does this make? This is like nonsense. First of all, that's not even right, because it's not big endian. Let's fix that first. Why is everything so broken? Is that right? Yeah, that is the right thing. I'm not sure. I'll give you a random capacity, but that doesn't even make any sense. Okay, anyway, the return logical bulk address is that. We need 2 there. So that would be 2, and it's big endian, so I actually want it like that. Yeah, the LSB is at the higher address. And that is... Yeah, that makes sense. So it's +1. Cap 0, 32. Actually, we can just do it like that. It's easier. And then we need the LBA thing. Okay, so that is 32 bytes, was it? Or it says read capacity 16, but it's actually 32 apparently. So in this case, the data length is 32. So command is 16, return data is 32, okay. Okay, so operation code, and EH. Yeah, that. We need the service action. We have that defined? No, I don't know what the service action is. Yeah, that's a 0. Oh, actually, we can just say 16 and then have allocation length 16, and I think that's okay. I think that should work. Yeah, I think that's okay. So I'm just kind of curious to see if that at least gets us a capacity. All right, there. Capacity 64. What did it complain about? Defined but not used. Okay, I guess that's not configured then. Config. Yeah, that. And of course, everything gets compiled now, and then cap. Invalid type argument of unary star. Oh, yeah. Okay. And then in 1549. 47, sorry. Okay. Probing for storage. Got some stall there. But did recover from stuff. Pass. Ooh. That's not right. Oh, because it's big India. No, it is right. Okay. But then that's not right. Oh, right, because I need that. Okay. So at least now we have the capacity set, right? Still stalling all over the place, though. So we have read 10 and write 10, and we're going to need read long or something, right? No. Read 10. Oh, wait. Read 10 does have a large-ish... No, it doesn't. So we need read 16. Yes. Might as well 64-bit since we are doing that there. 16, right, 16. Is that even defined with the right size? Because we're going to need a lot more than... As a command. Yeah, we have to 16. Okay, up to 16 for requests. Yeah, okay. So write 10 has a 12? Isn't that wrong? That'd be read 12 if it were the... Hmm? No, it should be 10. Isn't that another... Is that why it's failing? I mean, that's at least one bug. Read 16. Where does the lun go? Supposedly here. RD protect? No. Is this one of those things where USB... Hold on. I bet it's one of those things where USB mass storage is just overriding everything. Okay, hold on. Storage. $19.99. Didn't I get the overview already? Hold on, where's the overview doc? It's there, hold on. USB Universal Serial Bus Mass Storage Class Specific and Overview. The title of the document is AT Attachment 8 ATA Itapi Command Set. Good job, USB IF. Okay, but where is the actual... spec for the... Does it just reference SCSI or what? I thought I saw the... Is this one? Okay, yeah, so there is an overload here. So read capacity 64 doesn't work anyway, so how does this work for... Do they even have LBA48 here? I think they don't. I thought there was a way of doing this, though. Page 31. Without needing the... Okay, maybe we can't do this. I thought there was something... Without having to go to... to the USB attached SCSI. Okay, so read capacity 16 is supposed to work. Okay, it's supposed to work, but it's not working here. Actually, I can just say in 64. Okay, so that whole thing is failing and breaking everything. So after that returns, it's doing a bunch of stuff. It stalls, and then we end up exploding. So this is one good example of it going wrong. Maybe that doesn't support the 16 thing that I did. Capacity 64. So let's set the length to 32, allocation length to 32, and see if that's any better. And what about the buffer? Does this actually have enough space for that? P data. Sense buff. Get info. Cap. Okay, that just goes to cap, yeah. So we need that to be 32, which this is. And it's actually mem set it to 32. Read capacity. So let's see if that helps. Okay, so before that, I'm going to need the write 16 and the read 16. Where's read 10? Page 30. I hate PDFs without proper... Oh, no. Okay, so read 10 does have a command that is 12 bytes long. Why is it called read 10 then? I'm not even sure if that makes sense, but okay. Is that really the length? Is that not just a bug? Or like the spec being stupid or something? Hold on. See, this is why I hate USB. It's like everything is weird. So most commands, it says 12 bytes. Command blocks of exactly 12 bytes. Okay, so what about longer ones? That's CBI, though. We're not using CBI. We're using BVB. The bulk only. It says it's 12 bytes in length. Okay, so then the question is, Git Linux, what does Linux do in this case? Storage, unusual. Yeah, so there's a no read capacity 16 thing, but I mean, we do have that. So what about the command sizes? Is it always 12 or how does it work? Okay, transport. Uh, that's a request sense, though. Oh, is it because there's more than one subclass? It's probably just request sense that is... Yeah, it's supposed to be 6 in real SCSI and then 12 in... Okay, so is this about the subclass then? Okay, so what about the reduce block command stuff? Okay, I guess that's what that is. Yeah, so this doesn't do any of the other stuff. How do we check the subclass? I should plug this into my main machine and just see what Linux is doing. In a sec. And actually, I should use a USB 2.0 cable to force it to not go UAS. One sec, let me go find that. So I actually couldn't find a USB 2 to Type A cable, but I could find a crappy USB 2 extension cable, which will do the trick. Okay. So what is Linux doing about this? Might as well just take a log, really, of USB stuff. So... that didn't work. No. Oh, I think it wasn't plugged in all the way. There, okay. So there's the hub. And there's that. Oh, it does say UAS. Wait, UAS works on USB 2.0? Well, either way, I want this that one. Okay, so what we have is mass storage SCSI bulk only. And then mass storage SCSI 98. Okay, where are the actual protocol types defined? Okay, so 80 should be 50 in hex. Where's these things? BBB. And then UAS is 98. Yep, 62. Okay. So what about the command set? The subclass is supposed to say that. And the subclass is SCSI. Okay. So okay, so here's one problem. This is a SCSI device, not an RBC device. So SCSI transparent would not have the stupid length things there. So that's part of the problem. Okay, US data. We have subclass and protocol. Wait, we only handle UEFI, SCSI, and AT70? What is AT70? Because maybe it's just not handled at all. 5, removable media, obsolete. Okay, yeah. But we don't handle RBC. Okay, then those read and writes are wrong. Because then it actually is SCSI. We don't have RBC. Okay, yeah, so then we can just change those to actually use those. Because then the length is definitely wrong, yeah. because we're not dealing with RPC, we're dealing with proper SCSI. So then I was right, and those commands are wrong. And then we can ignore the RPC nonsense. And then the LUN doesn't even... Wait, why were we even... Didn't we have problems with LUNs? But we're not even accepting the ones with RPC. Wait, and... So then what do, like, card readers do? Because those have multiple LUNs. LUNs. Is this just overload? Okay, what does Linux do? So CB and CBI have max LUN 7. Bulk has nothing. Okay, there we go. RBC doesn't have a max LUN. SCSI doesn't have a max LUN. Okay, hold on. Right, okay, this is like fiber channel and SAS. Let's look up SCSI too. Uh, uh, what is this thing? This isn't right. There's like read and write. Okay, I don't know what this is. Let's try that one, but CD-ROM though. Okay, it sends CD-ROM. Okay, where's the capacity? Nowhere. Okay, this is like specifically CD-ROMs. Okay, just search for the CDB story. SPC6 rates on T10. Okay. Oh, that. Yeah. Oh, do I need to? Really? At least they didn't complain. Okay. Where's the actual like storage stuff? There's a different one. Ah, yes, SCSI3 block commands. Apparently that's... Wait. Okay, so that's not... Oh, this one? Okay. Commands. Port capacity 10. Just as reserved. Okay, so what about the LUN stuff? This is all like complicated. Just tell me what specifies that the LUN goes in the second word of the command. Something has to specify that. Other than RBC. Miscellaneous CDB information. What's that? Well, okay, someone tell me the story of the LUNs. Okay, so Wikipedia says it's there. Did it just get deprecated or something like that? Yeah, but then I want... Yeah, okay, so it was in earlier versions of SCSI. Where? Which up to which word? Okay, we'll just assume that's supposed to be there. But then read capacity 64, that service action thing doesn't look right because I'm probably sending it to the wrong LUN or something. So I still need an older version of that. Huh. Well, I mean, the LUNs field is there, but which probably means that should be there anyway. But LUN is 0, so that's not going to fix it. So I don't know why that's breaking. Oh, wait. Memset is wrong. That's a good start. What's control? SAM6 doesn't say. Hopefully I can leave it blank. Okay. Which means these are 10. And then that's wrong. That's, I need, okay, these are the ones I'm adding, but. So what about read 16? Read 16, operation code 88. We're going to assume the LUN is supposed to be there, and then we have the LBA in the next 8 bytes. Which goes like that. 32, 40, 48, 56. Transfer length is still 4 bytes. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then the transfer length is in 12 and 13 because we don't have that many blocks. And then write should be the same. Command len is 16. As we read 16. Okay, so let's look at where read 10 gets called. And then start here clearly. Okay, that is an LBA NT. That's good. Okay. How do I get the... how do I check for that? Lock dev. Probably in that. No. Wait. Oh, block desk, sorry. Okay, yeah, we can check the LBA. Yeah, basically that should work. Let's just do it like that. And do the same thing on this one. Okay. Let's see how far I am from that. Okay, so there's no write 16 defined. I need this SCSI stuff. Okay, so read 16 is 88. Oh, we do have, wait, 48? Wait. 28. Read 10 is 28. Read 16 is 88. Did I mess that up or? Write 16. 8A. Okay, some print, USB storage, 749. Let's just do it like that. It's a bit easier. Okay. I don't think that's going to fix much. Well, actually, I don't know. We might fix something. Huh. Did I just fix all the stalls? So I don't think it... No, it's not plugged in. I'm dumb. I plugged it into the computer. Okay. Hey, let's try that again. Okay. I think that still failed. No, okay, let's read capacity, the regular one. And we're still stalling. Yeah, so we are... Ooh, block size is wrong there. Oh, right, yeah, then I need... That is wrong. Need to put it in like that for that version, and then if... Actually, no. Just do it like that. I think I should just fix that stupid thing here. This doesn't make any sense. Okay, and then I should just make sure to cast that so that we don't overflow that. Let's just make sure. And then we can just do that. And actually, in this case, if 64 fails, we should just set the capacity to that. Should just not set it to anything, actually. We should just set the capacity to tilde 0 and then not touch the block size. Because that would be, the block size would be valid if we had the previous one. And actually, we might as well not set the USB ready thing on that one. So that should be okay. Okay. So why is read capacity 64 failing? I'm pretty sure that should work. Is it the service code thing that is not supposed to be set? Where's read capacity? 9E. The code is right. Occasional length fields on SPC6. I'm not sure if that's right. Okay, back to what does Linux do? So many workarounds for horrible stuff. Okay, so it's just set to RC16 len. And service action in... Whoa! Oh, okay. So it's not read capacity, it's... yeah, so the definitions here are wrong, even though I am setting them to the right values. call it SAI. And then here. Okay, let me just see if we're getting anywhere, but I think the length was right. It's RC16 len. It is 32, okay. Okay, so at least the fallback is working, but not the... Not read capacity 64, though. Why? Are we hard coding the command length somewhere? Also, this is read capacity 10. So it should be 10, not 12. And test unit ready. It's supposed to be 6. And request sense is also 6. Is it because are we setting the command size to 12 somewhere hard-coded? Like in the bulk only stuff? Or is that for the floppy? Hold on. So what about the floppy stuff? So nobody wants to break floppies, right? Okay, command block implementation requirements. Okay, that one does use 12 bytes for everything. Yeah, okay, so that's kind of why. Is it bool? Do we have bools in here? some of them do. Okay, so then problem is then I have the SRB here. I can't set the flags. US data is SS. Is that what I want? Oh yeah, it is. Okay. So let me go to all the command lines. Request sends. Inquiry is also 6 bytes. Okay, we actually want to use the CMD-len on that. Send diag. It's supposed to be also 16 bytes. Okay, that's just control block. Those are hard coded to 12, so that's fine. I don't know about 8070. That seems old. But then we should also accept the RPC. I just don't have anything to test that with. Okay. Might have to bring out the USB analyzer to figure out what's going on here. I mean, I could also first USB mon the Linux machine and see if anything funny is happening. Maybe there's a buffer somewhere for commands that is wrong. Okay, so the CDP is 16. What does that actually say about the bulk? Okay. Okay, so that's always padded to 16. That's right. Oh, and we actually have the LUNs in there. So I don't know about the LUN field in the SCSI commands. Supposed to resonate an IO accelerated family driven macOS. I'm not sure what that is. What do you think about Touhou's 19? I haven't played it. Actually, I haven't been following the games. I just end up listening to the music. Okay, so is it about the LUN somehow? I want that. Let's actually print that. It's 893. Yeah, US. Okay. Ooh, that's... Okay, so we are using commandants that are shorter, and that's fine. So battery capacity does that, yeah. And then tier 1, LUN 0, commandant 10. Commandant 10. Oh no, that's... Wait, where'd my 16 go? Oh, wait, no. That's not what I want. Okay, let's just move that out of the... Okay, so after read capacity, and there's 3 retries on that. Where's read cap? Okay, read capacity returns that. Command line 16, data line 32, ID 10, hold zeros, 13 is 20. Okay, let's look at the Linux one again. Yeah, 13. And nothing else set. That is 10. Oh, wait. And that is 9E. So why is it failing? So what we're actually doing is we are, let's see. Command phase, that works. Then data phase gets a stall. Oh, wait. This table isn't filled in, is it? Ah! Okay. Who decided this was a good idea? Okay, so service action in is 9E, and out is 9F. So that's 9. And then E is there, I guess. Bit 40. And then I bet the read command and write command also aren't there. Read 16 is 88 and write 16 is 8A. So that's 8, 8. So that is read, I think. Well, that explains a bunch of things. Yeah, that would happen if we're like reading or writing in the wrong direction. Of course it would stall. Okay, let's clear that. At least we're not timing out anymore, so whatever I did, I think helped. Okay, read capacity. Oh, I think it worked. Hey, that looks good, actually. Okay, so there's one timeout here. But we got through the read capacity. That's good. Okay, now what? Now the actual timeout. Why is it timing out on this one? Because this is what's breaking it. We're doing a read on dev0 start block 0 block count 1 buffer whatever. 88. That's the end pipe, I think. That would make sense. And then it times out. Is it possible that we are just timing out like because the hard disk is spinning up or something? Because that might be normal. We probably want like a test unit ready or something. Yeah, I can hear it spinning up. I heard it do something. I bet it's just it's spinning up. Hold on. So how do we set the timeout on this? Is wait for event hard-coded to some timeout? Oh no. Is this hard-coded? And of course there's going to be no. Okay, we do have a timeout in bulk messages. Why are we not using that? No. We have a timeout field. Why is that not? Interval. Submit bulk message. Submit bulk message. What does the USB layer do with the timeouts? Wait, is it? That doesn't make any sense. There's no interrupts here. How is that ever going to... We don't use interrupts. It's polling. Are we using it for some host controllers? No. That's for actually interrupt messages. What about OHCI? So it looks like OHCI does use interrupts. Wait. No, it's pulling. It's pulling anyway. Where did that nonsense come from? What? Where's that? In common? Wait, no. Where's that? Comment. (2002). And then no, that was there from the beginning. Control message. Initial revision. Literally initial revision. Like the whole U-boot. Looks like it. So status is, this is coming straight from UHCI, so that's where that came from. And then check scale. And then that gets called from, oh, because it used to have interrupts. It used to have interrupts in the past. And then they got dropped. So that's completely broken. So U-boot had interrupts in the past, and then that made sense, and now it doesn't anymore. Huh. Why is U-boot such a mess? Come on, has nobody fixed this? I guess we're fixing... This is ridiculous. Well, we're adding timeouts to those for one. And non-block, I don't know what that non-block, but... Okay, interrupt doesn't have timeout, so maybe that we don't need that. So let's not have it for interrupt messages, but for control and bulk we do. So where is that actually defined? Is it in uClass? Yes. Submit int message, submit control message, int timeout, submit bulk message, int timeout, bulk, timeout. Control and bulk get a timeout. And then bulk. You have the uClass as a separate thing by any chance? There. Okay. Not int. Int timeout. Bulk, not there. That one. Timeout. And control. Int timeout. And then I need to do all the other host controllers. I think that's all of them. Oh, it's CD, HCI, HCD, the brightness or whatever that is. Yep. And then sandbox. Okay, are we building at least? That's gonna be an interesting commit. Okay, common USB. Hey, Discord. Then this is nonsense. And bulk passes it to this one. Drops that. Okay, that compiles. Let me do a git on that. That needs to be fixed. Another question is, how many drivers do dumb things with timeout parameter? I would say most of them have some timeouts. Yeah. Yeah, control timeout has that. Okay. We'll buy that. And I need to fix the emulated one that I had a tab issue there. On that. Okay. This is not for M2 Max. This is for everything. Because USB support has been broken since 2003 or so. I think I just fixed like 6 bugs today so far. It's bad. This is bad. But then again, USB is horrible, so I don't blame the authors, but this is bad. Okay. So now we're actually going to implement timeouts. I think it's in milliseconds. Then bulk. Okay, so we need a header file for XHCI somewhere. Is that in here? Yeah, bulk TX. And control TX. Okay. Rebuilding so far. Close. Oh, apparently that's interrupt. Okay. No timeouts for that, so... Just say the end timeout is 1000. Submit bulk message, timeout, timeout. Okay, which isn't a non-void function. Oh, it's just the same thing. 1193. And timeout. Okay. Now we're getting somewhere. And then here, wait for event needs a timeout argument. Get timer. Is that what we want? No explanation. I assume it's in milliseconds. It looks like milliseconds, yeah. And just to be safe, okay, timeout. We're passing that through, and then in control transfer, and here we need to pass that to the event waits. So here we are going to use the default timeout. So we're going to use the timeout one. And honestly, the system stuff should be shorter. No point in waiting that long for that. XHCI says timeout, because we should have that for stopping stuff. Yep. Okay, wait for event. We need that on all those. So this is in control transfer. So that is actually going to pass through the timeout. Reset EP. Hopefully that is not too bad. And then it says timeout. And this is control, is it? Oh, yeah, that's bulk. Okay. Control transfer. And that should be sys, I think. I don't think we need the timeout on that one. Okay, we're rebuilding. Almost. Exciting. Wait for event. Is going to be sys timeout. Everything here is going to be sys timeout. Address device. Yeah, that better be. Device, all this stuff. Okay. 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 And now, well, okay. And now the mass storage stuff. Bulk message, and that shouldn't be controlled timeout times. Bleh. Wait, where did I put the one transfer bulk message? Yeah. Okay, so bulk message. CBW is fine. That doesn't need to have So stuff, but then pipe in, pipe out. Wait, this is data phase. Is that right? CB uses one transfer. Oh, okay. Okay, so we do need that on the other one, yeah, in the data phase for BBB. Okay. Yeah, I think that's fine. Okay. Let's do a bit of cleanup. Some of this stuff we can get rid of now, and that, and that, and that. Okay. Boot. And then let's add the support for that. Actually, no, that's wrong. I think that's fine. Okay. Where was the SCSI stuff at the end here? We are handling UFI. Okay, and then implement 64-bit stuff. What was the the size. 2 terabytes, was it? Yeah. Okay. And then we want to actually turn that on by default, because I don't think it was. And we definitely want that for the M1. Where am I? I just realized, isn't this breaking that we're not enabling that? Isn't that breaking the NVMe stuff on devices with more than... Oh no, because the sectors are 16K. Sorry, 4K. That saves it. So we're like borderline. What's the largest you can get a Mac Studio with? It won't be 8 times 2T though. That's the biggest Mac Studio you can get? Up to 8 terabytes. Okay. Yeah, so we are like 4 times out of it breaking. Not 16K, 4K sector size. Which is 8 times larger than the other one, and we are at... So we could do up to 16 terabytes. And then I'll have to check the NVMe driver to make sure that isn't hard coding things, but that's less likely because it would be relatively recent. Let me just do a quick check though. NVMe, PCI, and Apple. LBA, no LBA here. LBA shift, book size. Yeah, 64-bit. That looks very 64-bit to me. But then the then this is just getting truncated if it's 32-bits, which is not lovely. RW buffer read block count block number. Yeah. Yeah, this is all 64-bit, so that should be fine. But this is kind of broken. But I'm not going to fix that right now. Okay. And then all the debugs. Oh, I forgot to add the... I need all that. To fix up for this one. I don't think there's any read 6. Oh, 8. Ooh. Ooh. Does that mean AHCI is broken? Read 16 is definitely 8.8. Why does this care about... hold on. Oh, okay, no, it's looking for an overlying SCSI thing. It's looking for an overlying SCSI. Yeah, that's why. Which, honestly, the USB storage should just be using SCSI. I don't know why it's not based on SCSI. It probably should just be moved to be on top of that, but... But yeah, this only does 10, so there you go. That's why that never broke. So what about the capacity thing? Is there anything using that defined? Because I did move one of those. SCSI. Huh, okay, yeah, that's broken there. And SCSI is trying to use... Okay, that is broken. Yeah, that's wrong. Say I serve action in. So that needs to be a separate today. It'll be no. So I need to do it like that, and then I need to fix this. That's if it's serve action in. PCCB command on, and there was 3 bits on that. Just double check that. Yeah, 1F. Capacity 16. And then just let that fall back. then okay. And then in SCSI, read capacity 10. Yeah, okay, that's just done wrong. Subtraction in capacity 16. So then we add that, and I need to reorder these. So has read... Wait, no, this does have a read 16. Has this just been broken forever? I think it's just been broken forever. Because it's been doing read 12, I think, instead, or... Wait, what was the old value? 48? Is that a thing? Eight. No, I have no idea what that is. I think it's just been completely broken. Yay! 48. 48H. Sanitize. Great, we've been issuing sanitize commands, which... Isn't this one of those, like, wipe commands or something? Whew. Yeah, this doesn't sound like a good idea, does it? Instead of a read. Okay. Let's do a rebase and fix. Is that right? Hold on. Yeah, that is actually more debugging. And then I'm going to pick that before all the other things in storage. Okay. And let's just turn off all the debug and... is this really all the places I turned on debug? Hold on. And just make sure I didn't sneak any debug stuff in. Oh, I did. In USB storage. No, I didn't. Like that. No, yes, I did. Oh, wait, no, I want cached. Looks fine. Yeah, I think that's fine. Okay. Let's see how broken it is. Actually... wait. Yeah. Let's just stash it. See what happens without any... without any... debug. I think it's spinning up now. Yep, that was the hard drive spin up. It spun up, it read it, looks like it works. I mean, obviously it's a blank hard disk, so that's fine. I think I fixed it. Only problem is it's going to take forever on startup now. The way it initializes that, so it might be useful to have some way of making it not do that, but... or I actually, maybe just the thing I said about falling back on... no, actually, it would need that because of the keyboards. I need to be able to stop out to it. Anyway, it's not a big deal that it waits for spin up because, you know, the Linux is going to do that anyway. Well, maybe that's fine now. Maybe U-boot is not horribly broken anymore. Okay, but there's one more thing, though. Hold on. Alyssa said the USB like multi-output adapter thing from Apple made everything explode. I'm going to go grab that because I have one. And see if we find any other bugs or if we fixed whatever was causing that. One sec. Oh, hey. Thanks for the super chat. Okay, one sec. We're back. Okay, so let's see. I assume she was using it on a laptop. I assume it would fail the same on a desktop, though. Let's see why not. Okay, so I plugged in power. I don't know if that is required, but just in case, I plugged in a hub with a bunch of crap hanging off of it. I did not plug in HDMI, but I'm hoping that doesn't matter. So let's try that and see if it sees the devices and doesn't blow up. Okay, that is now broken for a different reason, but it did not explode. 8 USB devices found. That actually looks... Wait, is the keyboard working? Yeah. Wait, kind of. Yeah, it's just the... Yeah, and okay, so would be nice to see what that too many endpoints message is from, but it didn't explode, so... Let's see if we can work out what's up with that, and then I think we can call it a day. USB max endpoints. $16. Now, you can have more than that, can't you? But also, what USB device is that talking about? Why would it have that many endpoints? Because I only have some keyboard stuff. Oh, it might be the sound card, actually, come to think of it. Parse config. I guess just plug this. I don't know if it's the Apple adapter, but that doesn't even make sense that it would have any. Okay, hold on. Let me just plug this into my host and see what I have. I don't know what device this is though. Maybe I should print the device or something. Select config. Set up device. Prepare device. Device descriptor. Set address. Windows scheme of... Why is USB so cursed? Okay, hold on. Where? Set address. Control message, yeah. Prepare device. Where does it get the device descriptor? Get descriptor device size. Yes, that. Vendor ID. Okay, yeah. At least let's see what it is. Yes, 16 of input and 16 of output, but in this case it was more than... I mean that's 32 total, right? So not 16. But the question is it really that many, or is it that something else is broken? Okay, now we know what that is. Who is that? That is Texas. Okay, I knew it. It's the audio interface. Okay. Which shouldn't even be plugged in here anymore. But let's see if it really has that many. All right. Okay. Oh, it's because it's using the same endpoint many times. But because alt settings, right? It's alt settings that this is handling wrong because it's the same interface. More brokenness! Yeah, okay, so this is looking for interface sizes. Do we even have alt settings anywhere handled? Some gadget stuff. Nope. Num alt. No, it does have. Okay, num alt setting 1. Okay, so it does have alt settings, but then it just. Because the optimizer of GCC 4.x chokes on this routine when. Why do we have compile? God. Okay, so what about the set max packet? Set max packet, device, num endpoint. Is that the only thing this is used for? I think it's the only thing this is used for. And I don't think any actual are we ever setting the configuration with the alt setting? It's B configuration value. Back to USB spec. How does that work? Set configuration. Set interface is what it is. Yes. Okay, is there a set interface anywhere? No, it just sets it to like alt setting 1. Dev interface alternate. Alternate 1. Alternate settings, I guess, start at 1. No, it started at 0. Uh, Why is hub setting alt setting 1? Is that a thing? Multi-TT. Oh, right, because multi-TT uses an alt setting for that. But I don't think that would use more endpoints, though. Okay. Not break. Yeah, I do want to break, actually. Okay, another bug. Do you have a working debugger with stepping support? Actually, yes, but I like almost never use it because that's not actually that much better. Because like you have to break. It's honestly faster to just recompile and put a printf in there and run it, like than trying to figure out where to put the breakpoint and then inspect things. Okay. Yeah, no more errors there. I think it's fixed. Okay. Not that. So how many bugs did we fix? If we count all of the stupid, defensive stuff, that's 1, 2, 3. Not that one doesn't count. 4, 5, 6, 7. Well, that's not a bug. It was already broken if you got there. We'll call that implementation 8, 9, 10, 11, and then the 64-bit support, and 12. So 12 bugs in the U-boot USB stack. Oh, that explains why people were having a bunch of problems. Well, that was a productive evening, and I need to turn on the aircon because it's getting really warm here, because it's getting really warm in Tokyo, and it hasn't been turned on, and I need to figure out where my remote control is. And I should eat a little bit and then probably get some sleep. I'm just going to push this to Rilling. Not interface 0. Interface 0, you could still have alt settings, and the hub code is using that, but I'm pretty sure the hubs don't have different endpoint counts for different alt settings. I should check that, actually. You don't have a multi-TT hub lying around? I don't know. But I think it's just it's informative. I don't think it adds any endpoints. Is it expensive to run the aircon in Tokyo? Yeah. Depends on how many rooms you have and stuff. I mean, electricity has gotten more expensive here as it has, everywhere. Especially since, Fukushima, and they dropped a bunch of nuclear power, and yeah, not great, but I survive. Okay. Well, yeah, that was decently productive. I hope Alyssa's happy about how much is unbroken now. And now I can actually run my server. Okay. Well, thanks for coming. Let's see if we can get a release out pretty soon. That was, this and or disabling USB by default on the laptops was on my list, but I'm glad we fixed a bunch of crap. So that's good. All right. See you later.